Statisticians, welcome back to a new unit. At this point in time, we've wrapped up Unit 1 and Unit 2 and are segueing into exploring two variable data, specifically quantitative. Let's get into it. Since we're just starting off, we're going to distinguish between explanatory and response variables for quantitative data, so I can describe the direction, form, and strength of a relationship displayed in a scatter plot and identify unusual features. I'll know I've got it when I understand the basic properties of correlation, including how the correlation is influenced by unusual points. Here we go. So, oftentimes in different communities, there are multiple ways to obtain groceries. Sociologists use the term a food desert when it is more difficult for certain communities to obtain high quality produce and food that is generally considered good for you, as compared to the plethora of fast food chain restaurants. So we're going to look through some data in this particular lesson to determine whether or not our neighborhood determines our access to healthy food. First, we have to get a vocabulary word out of the way. Bivariate data is simply data with two quantitative variables, and we express bivariate data using a scatter plot as shown in the graph. Now, in this graph, we haven't labeled the axes, but we can see that as the x values are increasing, it appears that the y values are also increasing in somewhat of a linear fashion. We can't say that specifically, but there does seem to be some type of relationship here. So I'd like for you to establish some dialogue with your peers. And what are two possible categories that could have data and results like this that is shown in the scatter plot to the left? Be creative. Best response is going to win some extra credit on today's lesson. All right. So the data that you've been supplied here in this table is data actually taken from San Antonio, Texas. This is definitely a very real world situation. So down in San Antonio, they have the HEB grocery store, similar to what I guess you would consider here ShopRite in New Jersey. For each store, we have the zip code, the street, the average household income based on that zip code, and then the number of organic vegetables being offered. So, in a scatter plot, we say that the explanatory variable is the one that predicts, explains, or influences a trend in the response variable. The response variable is the measured outcome and it responds to the trends in the explanatory variable. So, based on these two definitions that you've just been provided, select of the four labels which particular data is the explanatory variable and which represents the response variable. All right, once you make your selection, we'll segue on to the next screen. Now, looking at our scatter plot that we've generated, you can see that average income would be considered our explanatory variable, and the number of organic items at a grocery store would be the response, right? What we're looking at and examining is the number of organic items as compared to the average income based on zip code. So don't forget the motto, title, label, tick, tick, tick. Now that we're getting further and further away from Unit 1, we don't want to necessarily forget our foundational knowledge. If you take a look at this graph, though, that's been generated, notice that it does not begin at 0. Scatter plots do not need to begin at 0. The goal with a scatter plot is simply to provide a very good visual of the full data set. So right now, I'd like for you to intuitively decide if there appears to be a relationship between the two variables. Does the average income of the zip code seem to have some type of effect or relationship with the number of organic items at our grocery store. There will be an explain your thinking box that appears here after you make your selection, so please make sure that you do that. All right. This screen appears to be a little tiny, so you might want to blow it up on your own laptop. But when we are discussing whether or not two variables in a scatter plot appear to have a relationship, we are contemplating the statistical concept of correlation. That is the nuts and bolts of today's video. So we define a correlation to be positive when as the x values, and when we say x values, we're talking about the explanatory variable increase, the y values, aka the response variable, also increase. So once again, we define a correlation to be positive when as the explanatory variable increases, the response variable also increases. Contrastingly, we say that a correlation is said to be negative when we do not say as the x values get negative, right? As the x values are continuing to increase, the y values are in fact decreasing. So on the previous slide, you were asked to determine whether or not you felt that there was some type of relationship between average income and organic items. Now that you've been provided with these two definitions and you have a visual here, right, a perfect positive correlation, a strong positive correlation, a weak positive correlation, no correlation, etc., etc., what correlation appears to be taking place between the average household income and the number of organic produce items available? Feel free to jockey back and forth between these two slides and make your selection. Now, once we do have a scatter plot and we start to discuss the correlation, we can then fit a least squares regression line. It is a linear model that approximates each type of positive or negative correlation. Note, and once again, you should probably zoom in here on your own screen. I'm unable to do that. But note that positive correlations have a line with positive slope and negative correlations have a line with negative slope. Least square regression lines are linear models that put roughly half of your scatterplot data above the line and half of your scatterplot data below the line. You might be sitting here thinking right now, how the heck do you even get one? That's going to come in a later lesson. For now, the main thing that I'd like you to remember is when we say that two quantitative variables have a positive correlation, the least square regression line has a positive slope. And when we say that there is a negative correlation, the data seemingly has a least square regression line with a negative slope. In this particular card sort, I want you to take some time and group these cards accordingly based on whether or not there is a weak or a strong correlation. I do have a auto checker built into this slide, so you can see whether or not you are trending, no pun intended, in the right direction. All right, so what we've done here on this slide is we've retrofitted our scatter plot with a least square regression line. So as we can see, and hopefully since you've passed algebra 1 at this point, we can see that the least square regression line has a positive slope, which indicates a positive correlation. This appears to have a moderate correlation. The data isn't necessarily too compact around the least square regression line, but it's not necessarily too far to say that it's weak. Anyway, I'd like for you to generate with your peers, since we're just kind of exploring, the following sentence. Average household income in San Antonio, Texas appears to be a moderately good indicator of insert blank here. Share that thought with your peers and we'll pick up all together. Now, back in Unit 1, we had learned the phrase seesawks to describe distributions. And those distributions were given in terms of one variable. When we have bivariate data, we are going to update our seesawks acronym to CDOFs. Now, it is strikingly similar. The C stands for context, once more. D stands for direction, whether or not the data is trending in a positive or negative manner. O hasn't changed, outlier. F stands for form. Right now we're looking at linear, but there will be instances where we're looking at non-linear regression. And the strength. Is it strong, moderate, or a weak correlation? So let's fill in these blanks here. Describe the relationship between the average household income in the zip code and the number of organic vegetables offered at the local grocery store. So the relationship between average household income and organic vegetables offered at local stores, some satisfying context, appears to follow a linear model satisfying the form, have moderate correlation, oops, wrong one, positive, and be moderately strong. Okay, so I've satisfied direction, strength, form. The last thing that I haven't satisfied is the outlier, and there do not appear to be any outliers from a visual argument. Now, it's important to not only be able to identify whether or not we have a positive or a negative correlation in addition to the strength, but there is a numerical value associated with correlation known as the correlation coefficient, which is represented by the letter R. It is a number between -1 and 1 that tells the strength, and I would say conveys the strength and direction of the correlation. So the closer an R value is to 1 or -1, the stronger the correlation is between the two variables. And the closer an R value is to 0, the weaker the correlation is between two values. So, in layman's terms, when we get a correlation coefficient that is 1 or -1, that means all of the data, as we can see here in the perfect positive and the perfect negative, is seemingly falling on this least square regression line. I'd like for you to reorganize this data, offering the correlation coefficients that convey the strongest correlation all the way down to the correlation coefficients that demonstrate the weakest correlation. Here we're going to estimate what you think the correlation coefficient is for this particular set of data linking average income and organic items. Like we had said previously, it is moderately strong and positive, so we should wind up somewhere on this side. But let's generate a bunch of different responses, or maybe similar responses, before transitioning on to our reflection slides. Um, does your neighborhood determine your access to healthy food? And then complete, as always, your reflection and synthesis. And we will pick up this conversation in class, looking at some pretty peculiar phenomena that have very relatively strong correlations with one another. I'll see you then.